Hey, it's This Week in Creationism special edition. Yeah, we're just gonna talk about one item, one article from Institute for Creation Research, where ICR explains the Yellowstone Supervolcano. We've got that coming up. Hey, Yellowstone National Park. I mean, who doesn't love that national park? You can't help but go there and be amazed. I mean, even if the traffic is horrible and it takes forever to get something to eat there, and you're sitting at Old Faithful and your kids are complaining because they think it's going to take it forever to go off because it's really not as faithful as it used to be. Despite all that, it's still a pretty awesome place, right? And Old Faithful, for me, it's just oozes geology, right? Geological history. And it has a lot to say about the history of this earth. All right. And you can see some of the forces that have shaped this earth right there in front of you. I mean, when you're at Yellowstone, you're inside the caldera of what we call a supervolcano. And what is a supervolcano? Well, it's a pretty super volcano, right? It just means it's really big. It's like a massive caldera, where the caldera is volcano blows its top because of the pressure inside. Huge amount of material is released. And then there's a collapse, all right, of material. And eventually you form this caldera, so this sort of cavernous feature in the inside. I mean, there's a mini tiny caldera inside of Mount St. Helens because it blew its top too. And then there's like a depression there. And there's a new volcano sort of in the center of it, which is much smaller. That's nothing like the super volcano of the Yellowstone region, where the mountains that are surround you are the edge of the volcano, not separate mountains that were formed. They were all part of one mountainous system. And then kablooey, massive explosion, ash that went up into the sky and fell over hundreds of thousands of square miles. I have to think about that. We'll say most of the West and then all the way out to Chicago. Chicago wasn't there at the time, but you get the idea. Covered a lot of area. So when I saw that Timothy Clary and Brian Thomas had published the first part of a series of really very short articles, so these aren't like research articles. These are just, talks about observations they made. Yellowstone National Park, Part 1, a flood supervolcano. Now, a year ago, maybe even less, Timothy Clary and Brian Thomas had gone out on along with others from ICR, they had gone on a research trip. And I knew one of the places they had gone to was Yellowstone. And they went to several other places to do a bunch of filming because they're making a whole bunch of short clips and videos that they want to produce. And so as part of that, they're writing lots of articles as well based on their experience, and they're sharing their own pictures from those locations. So here we go with Yellowstone. Yellowstone became the first national park in 1872, 2.2 million acre park. The park is unique for its travertine flows, mud pots, hot springs, and canyons, 10,000 thermal features, and over half of the world's geysers. I mean, it is a unique place on this earth. And people from all over the world flock to see Yellowstone. It's like right up there with the Grand Canyon, right, in terms of U.S. natural attractions. Now, look at these article highlights, and then we're going to talk about what's going on here. A supervolcano formed Yellowstone's national park's dramatic landscape, erupting during the flood about 4,500 years ago. All right, so they're stating, they're not hypothesizing here, right? They're not saying this is our model or our hypothesis. They're just saying to their audience, a supervolcano formed Yellowstone's national park's dramatic landscape. Okay, so they're admitting Yellowstone is the product of a massive volcanic explosion, right? So they're not denying that. But they are saying it erupted during the flood about 4,500 years ago. So while the world was experiencing a worldwide chaotic, watery disaster, that's when this massive volcano erupted. Volcanic evidence in Yellowstone and nearby demonstrates the rapid tectonic plate movements and catastrophic conditions that slowed dramatically after the flood. Now, that we're going to get to this in a moment, but there are other features nearby Yellowstone. And here they're stating the rapid tectonic plate movements. All right, so they're a subscriber to the plates of the earth. They are moving, and they will admit that the evidence that they're moving right now is accurate, that can be measured. We can measure how fast all the plates on the earth are moving this year, last year, for the last 30, 40 years, direct measurements. But they'll say that in the past, the plates moved much, much faster, and then have been slowing, all right, after the flood. So during the flood, these plates were like sliding along all over the earth, running into each other and so forth. And then as they run into each other, making mountains very, very quickly, and then pulling away from each other and making new seas and allowing the water to then fill those seas. And that's sort of the action during the flood, or the late stages of the flood. Now, point number 3 here. The magma that heats Park's geysers is evidence of the short time that elapsed since the flood and microbial life flourishing in the hot spring steaming waters. All right, so the magma that heats the Park's geysers is evidence for the short time that elapsed since the flood. They're going to make this argument, and again, I think it's kind of an appealing argument to the average non-scientist. Wow, look at that. There was a massive volcano here during the flood just 4,500 years ago, and so it's not surprising that if you had that much magma released there, and it's right below your feet, that it would have taken, after 4,500 years, it still hasn't cooled down, right? There's still a lot of heat below us. And then as you have water seep down into the cracks of the rock here in the caldera, it's meeting that hot magma, getting heated and expanding, and that's what's pushing it back up, and that's what creates the geysers, which is, in fact, what's happening. That's why the geysers are what causes the action of the geysers. All right, so the basic argument is there hasn't been a lot of time for all that magma to cool, and since it hasn't, that's evidence that it didn't happen that long ago. So like 4,500 years ago. All right, last point. Yellowstone's geological formations, unique geysers, and microbial loving hot springs point to the flood's effects, all right, and the creative genius of Christ Jesus. Okay, now they have a very simple description of what caused this volcano, and we're going to look at a couple other things that they neglect to mention that are rather difficult to squeeze into their timeline. Volcanic beginnings. Yellowstone's one of 12 supervolcanoes in the world. All right, so yeah, there are other locations in the world that are identified as supervolcanoes, and that's just a volcano that exceeds a certain mass and size of emitted or erupted material. Thick layers of volcanic ejecta from huge eruptions cover most of the area and beyond. No, most of the area, the surrounding states, all right, and even beyond those states. You can find evidence of ash, thick layers of ash that have come from this supervolcano. And by the way, it's not a single eruption. There's actually been multiple eruptions in the Yellowstone region over time. The middle of the park is a volcanic plateau that lies about 7,300 feet above sea level. Yellowstone Lake rests within this plateau, and the mountain peaks taller than 11,000 feet surround it, right? So you're in sort of these beautiful sort of grasslands, some flat areas that are in the caldera. You're at the bottom of what was essentially the collapsed portion of the volcano after the release of all this gas and ash. It is settled there into this flat area. And then the mountains around you are the edge of the volcano. The Central Plateau has 3 overlapping calderas. They're right, or collapsed volcanoes. And as you travel around Yellowstone, you actually travel from there are different sort of regions in Yellowstone. And in those different areas, you have sets of different thermal pools and so forth. Well, what you're really doing is you're traveling from one caldera to another, right? You kind of go up through a mountain or sort of a pass, and you go down into another flatter area. That's another caldera. The largest eruption occurred first, then the smallest happened last. So there was a huge eruption. Others, they're kind of like within that larger caldera or off to the side of it a little bit. This trend reveals diminishing power over time. All right, so they're saying, hey, there was a huge one and then there was 2 smaller ones instead of a steady process that uniformitarians imagine. All right, so there's a jab at uniformitarianism, as if geologists believe that volcanoes have to be the same intensity each time that they erupt. That's not what uniformitarianism holds. The scenario fits what we would expect as Earth recovered from a tumultuous flood about 4,500 years ago. Oh, this flood time was so chaotic and lots of crazy stuff was happening. Continents are moving around. So you would have, their expectation is you would have had wild and enormous events occurring and then slowly dissipating or even rapidly dissipating toward a time of more quiescence that we experience today. All right, so I guess that would be a prediction, I agree, of young Earth creationism. Geologists noticed a line of older calderas. Now, here's where it got really interesting. It was one of the reasons why I wanted to talk about this separately from my other young Earth This Week in Creationism stuff. Geologists noticed a line of older calderas that extend from Yellowstone to Oregon. Conventional scientists consider this trail to have formed over a mantle hotspot as Earth's crust slowly moved across it over millions of years. However, millions of years age assignments rely on assumed evolutionary timeline, not directly on data. Now, they immediately avoid talking about the obvious problem here. It's not the dates. It's the fact that there is an observation that there are other calderas from Yellowstone all the way over to Oregon. And even if they are dated to be millions of years old, well, even the Yellowstone ones are dated to be millions of years old already. Yet they agree the Yellowstone volcano happened, right? I mean, we just saw that. They're saying you're standing inside of if you go to Yellowstone, you're inside of a supervolcano. And that supervolcano blew its top during the flood. What then happened to all these other calderas? There's a whole series of calderas that go from Oregon to Yellowstone. Each one of those calderas must represent other supervolcanoes. Now, conventional scientists or conventional geologists, we'll just call them geologists, all right? They would argue that there is a hot spot in the mantle, all right? So there's a hot spot deep down in the Earth's below the crust. And below the crust. And as the plate moves over the crust, right, the continental plate that is North America, as it's moving across that hot spot, magma comes up, melts through the crust, and then gradually creates this volcano. Well, a lot of magma moved up through there, and the type of magma that it is interacting with water created very explosive events. And so you had a huge eruption creating a large caldera of a supervolcano. But then the crust kept on moving, and so that caldera moves away from the hot spot, right? Then there's another blob that comes up, melts through the crust, and then creates another supervolcano, and then the crust is still moving away. And so you end up with a string of supervolcanoes, or calderas. And today there's a caldera in Yellowstone that is considered to be the youngest caldera by geologists, right, by radiometric dating. But not just by radiometric dating, but also just by sheer sight, right? You see the calderas, and one is really worn down, and there's no magmatic activity, and there's no geysers. It's cold, right? The crust is cold. And then as you get closer to Yellowstone, the calderas are a little more obvious because they're not as eroded, because they're younger. And then you get to Yellowstone and you have the youngest caldera. And guess what? It's really hot underneath it because there's still magma there, right? You're still over the hot spot, which means there's potential for another explosion in the future in that general area. All right, so if you go back and we're saying, remember the one bullet point here was, this is evidence of a young Earth. The fact that there are geysers there. Because this only happened 4,500 years ago, and it hasn't had enough time to cool down. And therefore, the Earth is young. This is one of our, hey, a nice, interesting way of showing the Earth is young. Well, what about the other calderas? The other calderas are cold. They don't have any geysers. They don't have any hot spots there. And yet, they're supervolcanoes. And when did those happen? Well, they must have happened during the flood, too, because they're sitting on a crust and they're spewed out material on top of sedimentary layers, which presumably were laid down by the flood. So they're late. They were produced late in the flood, period, just like Yellowstone was. And yet they're cold and Yellowstone is hot. No mention of that in this particular article here, right? They're not applying the logic that they are using to come to their young Earth conclusion to the other obvious evidence that the other ones are cold and they should also be hot as well, right? They should also have geysers at this point because they should still have just really hot rock below them because it's only been 4,500 years. After 4,500 years, if you have a large amount of magma sitting below the surface, it's going to be still hot after 4,500 years. Look, conventional geologists are saying that Yellowstone is still hot, and it's been 600,000 years since the last explosion. Oh, wait. We'll get to that. I can't remember if it's 200,000 or 600,000. But I have a figure for that. Oh, yeah. So the top part of this paragraph here is just, again, trying to convince you that, hey, this is hot because it's only been, a couple thousand years since this happened. All right, go back to there's other calderas that are cold. So how are you going to explain them? Because they're happening roughly within a year, actually within a month of the Yellowstone supervolcano. The other supervolcanoes must have gone off. And we're not even talking about the vast amount of ash that would have been thrown into the atmosphere by one volcano, right? One supervolcano would have affected potentially the whole world's climate for a short period of time. But then we're talking about 7 or 8 different calderas, all supervolcanoes, all going off within a month's period. You're talking about just this one place on Earth having a huge effect, and we're not even talking about the other 12 supervolcanoes in other parts of the world, which according to ICR now must have probably all happened right during the very end of the flood. What's their conclusion here? Yellowstone is a beautiful and awe-inspiring reminder of the global flood. Calderas and thousands of feet of volcanic rock. Yes, thousands of feet in some places of ash and rocks that have been thrown out here on top of sedimentary rock that must have been laid down, in their view, by a global flood, is a witness to great catastrophes that occurred during the flood year. The magma that provides the active geysers has not yet fully cooled, which is what we'd expect, or what would be expected with the relatively short time since the flood. All right. Do I have to get all shocked again by the fact that they're not mentioning all the other calderas and the fact they don't have that? Okay. They talk about some other features of Yellowstone, but let's get to really the most critical thing here. Let's talk about these other calderas, and then I want to talk to you about the effects of this on the rest of North America. And why does ICRs say that this happened during the flood? Right? They make it sound like this is when it happened. It's not even a hypothesis for them. It's kind of like, this happened during the flood. That's not what other young Earth creationists say. Other young Earth creationists say this is a post-flood event, that these massive super calderas happened after the flood, while organisms that had come from the ark were living there. And I'm going to show you why they say that. And I think those other creationists completely destroy this particular argument of ICR. I don't think ICR has thought at all about what they're saying here. Okay, here we go with the calderas. Let me get my pen. Oh, I'm already ready. Here's Yellowstone. Here's the current caldera, the Yellowstone caldera. And the reason for the age range, 2 million to 600,000, is because, just like the article mentioned, and even ICR seems to admit, there were 3 separate eruptions. One very large one, and then 2 smaller ones. The largest one is dated to be about 2 million years old by conventional dating, and the youngest one about 600,000 years old. And between those, all right, so you have really thick layers of ash that are associated with especially the first volcanic explosion. And then what you have is you have a lens in which you have basically you have sediment, you have soil. I knew there was a basic word I was looking for. You have soil that's produced on top of the ash layer, and then you even have forest growing in that soil, right? So you have all these fossils of forest there. And remember, I don't know if some of you will know that there are some very famous buried forests that are still standing trees that are in the ash layers. Well, then you have another explosion, and you have a large layer of ash set on top of that from one of the other ones. Then you have, in some places, you have more soil built up, and then you have another thick layer of ash. All right, so you have a large segment of stuff that is ash and soils and so forth. Now remember, ICR is trying to say all this happened during the flood in water, right? I can understand massive plume of ash coming up out of the water if it was huge enough to push the water aside, but it's going to fall into water. And as far as my reading of the ash layers found in Yellowstone, I don't see much evidence that they're laid down in water. All right, so they got a problem there, but the problems get much bigger than that. So here's Yellowstone caldera. But now let's look back here. There's something called the highest caldera in Idaho, and it's dated to 6.6 to 4.4. And again, because there's multiple different volcanic explosions, and the ash from these is all over this area. And then you have another caldera that's 10 million years old, then another caldera that's 10 to 8 million years old, and then you have this 12 million year old caldera, and then you have this 13 million year old caldera, and then you have this 16 million year old caldera. And the idea is that the hotspot the hotspot stayed in one spot, but the continent has been moving this direction. And today, that's the direction the continent is moving. And so originally, this particular caldera was over here, where it was produced here, but then the continent moved off this direction, and it's moved that far away, and that's why they're lined up in order of timing. So young Earth creationists say, I don't believe the dating. And I say, okay, don't believe the dating. This caldera is much more worn down and is cold. And then as you move this way, the calderas become more obvious because they're less worn down. And you get to what is really obviously a caldera because you're in the neck of a volcano that's still hot, right? And there's still magma underneath your feet. All of this had to have occurred in a few months' time in a global flood scenario in the ICR model, if they're going to say all this happened during the flood. But now let me show you why this did not happen during the flood. All right, and I don't know if ICR's writers just don't do their research, don't consider other data, and they just throw out an answer to some observations they made while they were traveling through Yellowstone themselves. And it's like, oh, this must have been from the flood. And okay. And then they found some data that seemed to fit their model. But it doesn't even fit the explanations of other young Earth creationists. And here's why I say that. There's a great fossil site in Nebraska. It's called Ashfall Fossil Beds. And Ashfall Fossil Beds is this building that's been set up on top of what was a grassy plain hillside where a bunch of fossils were discovered, and they're embedded in volcanic ash. Volcanic ash is super good at preserving organisms. So if an organism is hanging out and then a massive amount of volcanic ash falls on them, well, they get suffocated because they're breathing in glass, because volcanic ash is essentially glass. They breathe in this glass, they die, they fall down, right? And they lay there, get covered up with ash, and the ash is a super good preserver. And so they have these entire fossils, right? The entire organism of a bunch of different animals. And these are all ice age type of animals. And guess what? If you have ash and you can look at it and you can analyze it chemically, you can usually figure out where the ash came from. This ash came from one of the supervolcanoes, right? But this ash didn't come from the Yellowstone Supervolcano. This ash came from, most likely, right, this particular supervolcano right here. Each one of these volcanic eruptions has a different mixture of water, and the magma coming up from the earth changes its various ratios of elements because it's mixing and melting the crust, all right? And the crust is different in different spots. And so as a result, each one has its own, you could call it a chemical fingerprint. That chemical fingerprint from the Ashfall fossil beds fits this particular eruption. Now, you're asking yourself, all right, so there was this eruption and massive plume of ash goes up, and you're talking about had to go all the way over Wyoming, all right, then all the way over across, because this is in western Nebraska. So you go all the way over to western Nebraska. You're 800 miles away now. And even 800 miles away, you had enough ashfall to be able to suffocate and kill and cover large, all right, mammals and completely preserve them. Now, the scene is thought to be something like this. All right, this is sort of your ice age scene. This is a picture from Ashfall fossil beds. And so you have a whole bunch of different kinds of horses. You have rhinoceroses, which there were rhinos in North America at one time. And there are also, let me get to, here's 5 different species of horses found just in the area of this particular preserve site. 5 different species of horses. Not 5 varieties or breeds, 5 different species of horses. And you say, and notice that some of them are 3-toed horses and some are 1-toed horses. All right, so significant genetic differences between these. So 5 different horses, none of which are alive today. These are all extinct species. 3 different types of camels, right? There were a lot of camels in North America in the past. And there's a rhinoceros there. And there's a type of extinct deer. All these organisms are extinct today. And then there are 3 different kinds of dogs there. But one of them is a bone-crushing dog, and it's one of the rare samples of bone-crushing dogs that are from North America. And the bone-crushing dog is considered to be a sister group of the canines, or the canids. So foxes and wolves. It's not considered to be in the group of foxes and wolves. It's considered to be a separate group next to them, which may or may not be a different family of canines. And so something quite different than the rest. All right, so imagine all these different animals. Now, where do all these, let's think about ICR. If you know anything about what I've said about ICR before and others, ICR thinks that all the horses are one kind, right? And so there was 2 horses on the ark. The 2 horses got off the ark. They spread across the earth. They filled the earth and diversified into all the different species of horses that are in the fossil record, because that fossil record is considered to be post-flood. Well, wait a second. Wait a second. Do you see the problem? This ash that preserved these horses and all these different animals that we kind of consider to be ice age organisms or recent living things on Earth, and that most young Earth creationists consider to be post-flood because they believe the ice age was right after the flood. But wait a second, these were covered in ash that came from a supervolcano that is older than the Yellowstone volcano, but ICR just said in this article that this happened during the flood. So now what we have to say is, during the flood, there were 5 species of horses, 3 species of camels, some rhinoceri, a deer, and 3 types of dogs. 3 types of dogs, all these different animals, all found in one area, all perfectly well preserved, the entire organism, and all in volcanic ash, just a pure section of volcanic ash. How were they standing around on top of thousands of feet of sediment, which were laid down by the flood? Right? So the flood is chaotic, destroys the earth, piles up thousands of layers of sediment, and on top of all that sediment, you had all these animals hanging out in a very close area, which is why they think it was basically a watering hole right here. And then now they're compacted into a layer of ash. And then on top of that, there are other layers of sediment and other layers of ash from other supervolcanoes that come later in the area of Nebraska, also have additional layers of ash. Wow. If this happened during the flood, it has implications for a bunch of other things having to do with what a kind is, because all these animals weren't on the ark then. They were killed beforehand, but they're really similar to the species that are alive today. So how did something get preserved on the ark, and then horses come back to North America, but they're not related to these horses because these horses all were killed in the flood? And you have rhinoceroses, and you have all these different animals that are closely related to things that are alive today, but they're not part of the speciation that happened after getting off the ark. And yet, after animals got off the ark, they became 35 different species of canines. They're living in these same areas that these other canines were living. I mean, this is just mind-boggling stuff that I just don't understand how ICR doesn't think, at least try to think through some of these things and look at some other sites and go, wait a second, if we go with this model of this supervolcano occurring during the flood and then depositing all this ash all over North America during the flood, then we can explain all these fossils as being post-flood animals. And now we have like a bunch of pre-flood animals that look just like the post-flood animals, but they're not really, they're kind of related to each other through just 2 animals. I don't know. It creates one problem on top of another problem. It's making it hard for me to even talk about it here because I can think, my mind is reeling with 100 different problems, and I'm trying to figure out what are the most essential ones to tell you about, because we could go off on rabbit trails on all these different things. So the Ashfall fossil beds, and this isn't the only place where organisms are preserved in ash. There's lots of other locations in North America. But the way I'm reading ICR, we'll see what happens with part 2. I'm doing this even before part 2 comes out. The way I read ICRs talk about supervolcanoes is if they're trying to make them be part of the flood. And the reason they're doing this is because, remember, they think that the flood boundary is very, very high, that only a little bit of the fossil record is post-flood. Now let's switch to Answers in Genesis. How would they respond to this? I think that Answers in Genesis, since they think that the flood boundary is way down there at 66 million years, the conventional date at the Permian, the Cretaceous Paleogene boundary, since they think the boundary is way down there, they would say that all those supervolcanoes from Oregon to Yellowstone are all post-flood events. So in their mind, horse got off the ark, horses became other horses, horses migrated to North America in the first couple hundred years after the flood, across the Bering Strait during the Ice Age. So during the Ice Age, horses migrated into North America and they speciated into a variety of different kinds. Some of them might have been gathered at this watering hole in Nebraska, what would become Nebraska. And then supervolcano goes off, massive amount of ash buries them. These fossils are not flood fossils. These fossils are post-flood fossils. See, not all fossils were formed in the flood. even though some young Earth creationists like to try to make it sound like the only way you could make fossils is it had to be a massive worldwide event. No, it could be a massive volcano, but that volcano wasn't a worldwide event. So answers in Genesis, and I think really most other young Earth creationists, I think if push comes to shove, I think they're going to say that this particular site, Ashfall fossil beds, is a post-flood event for the very reasons I'm just giving you. It doesn't make sense that these animals could be reserved in ash that came from a volcano that was going off during the flood. That just is not easy to explain. I don't think it's easy to explain horses getting all the way to North America, becoming a population, along with rhinoceroses and deer and a bunch of different types of dogs, all of them having to migrate from the ark, speciate into these different kinds, produce populations and have an ecology there, and then have it covered with ash within the space of, a couple hundred years? That seems like a stretch as well, but at least it's a stretch of timing, whereas ICR just has this is completely incompatible. Yes, it doesn't fit at all. Okay, so ICR ignores the other calderas. Well, they mention them, but they forget to think about what the other calderas could possibly mean for their model. You can't say that there's active geysers here, therefore the Earth is young, when there's no active geysers down here, even though that volcano went off around the same time. It just isn't a good argument once you start to think about that other data. And all of these produced huge ash layers that are found all over different states. And they can be dated to different intervals, and there's layers of soils between them. And so that represents time as well. So how would you get soil development and a forest during a global flood between two different supervolcano explosions? And even in the Answers in Genesis model, how would you get a forest developing if you had to have all these supervolcanoes and they all had to happen probably within 400 or 500 years after the flood? Because by the time, people are going to get to North America pretty soon after the flood too, right? At least after Babel, you have Native Americans. It's kind of hard to live in a place where you have supervolcanoes going off, and yet we have evidence of Native Americans having lived here for thousands of years themselves. And so the land had to have settled down by that point, and the supervolcanoes are basically not active, all right, for a long period of time. Okay, that's my story about Yellowstone. Now, if you want to learn more about Yellowstone, the real source for a lot of this and a lot of thinking about how Yellowstone fits in or doesn't fit in with young Earth creationism is to go to the GeoChristian's blog site, right? And so I will put a link to that. GeoChristian has written a number of articles about Yellowstone and the problems that young Earth creationists have with Yellowstone. Hey, thanks for listening. Hope you enjoyed this. If you did, hey, subscribe to my channel, and we'll be back with This Week in Creationism or other projects that I'm working on. I'm going to be doing several things with a bunch of geeky molecular genetics type stuff. But I also hope to talk about some things that are a little more theological as well in the coming months in the summer. So trying to branch out and kind of like cover a wide variety of different topics. There's a little bit for everybody coming up in the next couple months. Thanks. Talk to you later. Bye-bye.